Okay, welcome back. So to finish this section, our last topic is going to be limits at infinity. So here's a definition box of limits at infinity. So limits at infinity, we get also horizontal asymptotes, a word that or a phrase you should be a little familiar with. But if f of x becomes closer to the limit as x becomes larger and larger, then we write the limit as x approaches infinity of f of x equals some specific limit. So what do I mean by that is say we have some visual representation, right? And you know, here's your y, here's your x, and you know, say we're going off to infinity, right? Say we're going off to infinity, but we're not being able to pass this specific line, right? Well, that means that as x goes to infinity, the limit of this function would just be that line L. All right, so this is just some horizontal line, but that also means that it's a horizontal asymptote. It doesn't pass that line. Okay, so we call the line y equals 0 a horizontal asymptote. Okay, so likewise, if you're going in the negative direction, right? So we kind of draw that here. Okay, so say I'm going in the negative x direction, right? Separate graph, but kind of the same thing. Say I'm going in the negative x direction, right? I'm going that way, but there's a specific line that I can't go through. Well, that means this limit would be m, and that would be the horizontal asymptote at y equals m. That as we go to negative infinity in the x direction, we just can't cross this guy. That would be the limit. Okay. Now that we have that down, let's check out some examples. So find the limit of x cubed as x goes to positive infinity and the limit of x cubed as x goes to negative infinity. So luckily it's graphed here. So from the graph of the function, we see that it blows up to positive infinity on the right and negative infinity on the left. So that means if we get bigger and bigger values for x, right, we're going this way, we get bigger and bigger. We go up to infinity. So we'd write the limit as x goes to infinity equals infinity. So it's not always a case where as we go to infinity, we're going to meet some stoppage. It might be the case with this as we just keep going to infinity. So the limit as x goes to infinity equals just infinity. So if x gets big, then y gets big. Similarly, if we go off to negative infinity, right? Sorry, if our x values go to negative infinity, that means our y values are going to negative infinity for this function. So as x goes to negative infinity, our function goes to negative infinity. Okay, so that is a brief introduction about in limits at infinity when x is approaching infinity or negative infinity. So kind of recall from the previous page about vertical asymptotes is that a vertical asymptote is a line where a function approaches a positive or negative infinity. Okay, so that example we already checked out was f of x equals 1 over x on the previous video. And so we were checking around x equals 0, right? So here's a graph again. So as we approach 0 from the right, the graph shoots off to positive infinity, right? So we would write equals infinity. And likewise, as we approach 0 from the left, it shoots off to negative infinity. So we would write the limit is negative infinity from the left. And since it blows up at x equals 0, we see that a function has a vertical asymptote at x equals 0. So the key word here, this is the same type of verbiage you hear me say, it blows up, meaning like 0 on the bottom, that denominator, blows up. What x value makes the function blow up, meaning 0 on the bottom, meaning undefined. Okay, so this value that makes the function blow up is your vertical asymptote. Right, so x equals 0. If I plug in 0 here, what's going to happen? Well, it's 0 on the bottom, meaning it's undefined, means it blows up. So that is our vertical asymptote. Okay, so we're going to try this out in the following example. So before I even get to these examples, there are some ways to solve limits at infinity when x is going to infinity, right? There are many ways to solve it. In terms of writing the sort of steps, here's down the firm. I'm going to write it on the previous page. So there's really three ways to solve limits that go to infinity or limits at infinity. So I'll write limits at infinity, meaning when it's like x going to positive or negative infinity. So it's really a way to solve these, a quicker way. There's other more mathematical rigorous ways, but for this course, we'll look at the fastest way. So here's one option you'll have. So one, if the x power, I'm writing x in quotations because it might not always be x. It might be some other type of variable like y or a or b or n, right? But if x power in the denominator is bigger than numerator, then the x power in the numerator then the limit is 0. Okay. So it could be something like x squared over x cubed. Well, this would just be a limit equal to 0 because the power in the denominator is 3 and the power in the numerator is 2. Okay, so that's one option. Two, if the power in the denominator is smaller than the x power in the numerator, then the limit is going to be either positive or negative infinity. Right, so for this kind of example, if you have something like x to the fifth over x to the fourth, the power is 5 up top, the power is 4 on the bottom, so your limit would be infinity. And then negative is just if there's like a negative somewhere in there that's affecting it. So this would be negative infinity. But that's the second option. And third, well, what if the power is the same? So if the power in the denominator and numerator is the same. Limit, I'll say the limit, is the ratio of their coefficients. And what I mean by that is if you have something like x squared over 2x squared, same power, they're both the second power. So what this means is the limit is going to be the ratio of their coefficients. So the limit would just be 1/2, right? Think about this invisible one right here. But that's what it means, that it's the ratio of their coefficients. Okay, so that's kind of a problem solving strategy for limits at infinity. You're either going to have these three options, okay? And like I said, this is a quicker way, and there's more mathematical, rigorous ways, but in terms of this course, let's just keep it simple, okay? So let's go ahead and try out this example, right? It's the last bit of this section. So find each of the limits below, right? And then state any vertical or horizontal asymptotes if they exist. So let's look at this first one here. So limit as x goes to infinity of 10 over x squared. So if we look at this, right, if we look at the powers of this one doesn't really have a power. You can think about it as like x to the 0, but that's just the same thing as 1, and then x squared. So if the power in the bottom is bigger than the power in the top, what category does that fall into? It's going to fall into option 1, where the limit is just going to be 0. So I'll just make a little note like um, note power in bottom is greater. So I'll decide, but then I'll say limit this thing just equals 0 because power in the bottom is greater. Quick, right? Quick answer. So what this means though is that since we have a limit that's going, x is going to infinity, and we're actually getting a numerical answer, that means that it's a horizontal asymptote. So a horizontal asymptote, so let's say horizontal, I'll kind of abbreviate this. Horizontal asymptote is at y equals 0, this guy. Okay, so that would be our horizontal asymptote. And then our vertical asymptote, when is, remember, it's when it blows up, right? So you got to set denominator equal to 0. So I'll say set denominator equal to 0. Okay, so let's go ahead and find that out. So up here, the denominator is x squared, and I'm setting that equal to 0. And then, you can take the square root of both sides. You should get x just equal to 0. So, let me erase this. And then I'll just write vertical asymptote is just x equals 0. And I'll make a note over here. Set denominator equal to 0. Okay, and that's how you would do that problem. Okay, so let's check out this next one. So if we look at this, limit as x goes to infinity, x plus 7 over 3x plus 5. So if we look at this and we look at the highest powers in the numerator and denominator, the highest power here is just an x, and the highest power here is just an x. So they have the same power. And what that means is that we're going to take the ratio of their coefficients. So the ratio of their coefficients, you can think about this just having an invisible one right there. So the limit as of this would just be 1/3. Quick. Okay. And then you can just make a note to yourself, like note power is the same took ratio. Okay. So that's a quick way to do that. And just keep going. Horizontal asymptote. Remember, the horizontal asymptote is basically what your limit is. You're taking this limit to infinity, and you got some horizontal asymptote there. So that would just be y equals 1/3. Okay. And then your vertical asymptote, remember, it's when this guy blows up, right? So you got to set your denominator equal to 0. So let's go off to the side here and let's do that. So we have 3x plus 5 equals 0. We move the 5 over, we get 3x minus 5. Divide by 3, and we get -5/3. And so your horizontal asymptote would be -5/3. Okay. So next one is limit as x goes to infinity, 7x squared plus x minus 100 over -2x squared minus 5x. Um, so what we have here is once again the same power in the denominators. I know we have other x values going on, but we're just checking out the highest powers in the top and bottom. So what happens with that? We are going to take the ratio of their coefficients. So the ratio of these is just going to be basically 7 over -2, which is just -7/2. And that's our limit. Okay. So once again, that means our horizontal asymptote is going to be -7/2. Okay. And then likewise, our vertical asymptote is going to be whatever makes the bottom 0. So we'll just go off to the side and write, -2x squared minus 5x equals 0. So we might get two values here. So what I'm going to do is factor out an x, -2x minus 5 equals 0, and just solve for both of these individually. So x equals 0 and -2x minus 5 equals 0. So that's one of the values already, and we just solve for x for this guy. So we move the 5 over, we should get -2x equals 5. Divide both sides by -2 and get -5/2. So our vertical asymptote is going to be at x equals 0 and x equals -5/2. Okay, so next one is D, right? So here we have x squared minus 3x plus 7 over x squared x cubed plus 10x minus 4. And what we are going to do is look at the highest power. So we have more x values going on, right? But we're going to check out the highest power. So highest power up top is x squared, and on the bottom is x cubed. So the power on the bottom is greater. So which one does that fall into? It's going to be option 1. Denominator is bigger power. So this one is just simply 0. And so what that means is that the horizontal asymptote is y equals 0. Okay, so vertical asymptote is when this guy is 0, right? So let's go ahead and figure that out. So x cubed plus 10x minus 4 equals 0. So this one is more complicated than before, right? We can't just like set equal to 0 and solve. And also, this is just not factorable. We can't factor this at all. So, simple trick is to just graph this guy and see where it crosses 0. So I'm going to make that note. Graph and see where it crosses the x-axis. Okay, that means it's like in basically finding x-intercept. Okay, so what I'm going to do is just go to Desmos and graph this guy. Okay, so here I am, and I already graphed it right here. So if you look at this graph, I'm going to zoom in. It looks like it's crossing at some point 0.393889. Okay, sure. You can go ahead and just say that's where the vertical asymptote is. So 0.3939. Okay, so we'll say that. And you get so, and then what you end up with is x equals 0.3939. Okay, so that's our vertical asymptote, 0.3939. And then likewise, in the future, if you graph any one of these bottom ones that we just solved for x, you'll see that it crosses at those x values that we find. So for this one, 3x plus 5, we found to be negative 5/3. If you graph that, you also find it crosses there like we just did. Okay, that's pretty much it. And let's try one more. Um, let's see, we have 7x squared here and a negative x here. So the power on the top is bigger than the bottom. This is a power of 2, that's a power of 1. So what we end up with is going to be just infinity. Okay. And that also means that our horizontal asymptote is none. Since it's going out to infinity, there's nothing stopping it. It's not reaching anywhere. It's just going to infinity, so there's no horizontal asymptote. Okay, so vertical asymptote, we actually can find that. Remember, it's just when the bottom equals 0. So go off to the side here, 4 minus x equals 0. And you just move the x over. And so vertical asymptote is just 4. But okay, so that's how you solve infinites, limits at infinity, going to infinity. But okay, so that's it for this video. See you next time. Thank you.